Today for topic 1.3, we're going to be looking at angle measure. We're going to start off with some vocab and taking a look at a diagram, making sure we know how to label everything properly and identify things. So our first word to define is angle. And I know you guys know in general what an angle looks like, but we need our formal definition so we can see all the parts of our angle. So first of all, an angle is formed by two intersecting rays that have a common endpoint called the vertex, and the rays are called the sides of the angle. So if you take a look at our picture up at the top right here, we actually have several different angles being shown. One angle is this one right here, okay? So that angle is formed by two rays, ray YZ and ray YW, and they both intersect at Y. So a few things to write down here. First of all, both of these rays intersect at Y, so we can go ahead and state that that's the vertex. We're going to do that in the example portion over here. So vertex is point Y. And then remember, the sides start at your vertex. It says here, formed by two intersecting rays that have a common endpoint called the vertex. So our common endpoint is Y, and then from Y we head towards Z. So one side of our angle is ray YZ, and the other starts at Y and heads towards W. So the other side is ray YW. Now what if we just wanted to name this angle? Well, there are several different ways to name it. One way, and probably the way you'll see the most often, is with three letters. It's the three letters that you see actually along your angle. So you could name this angle WYZ because it starts at W, heads towards Y, that's your vertex, and then back around to Z. So angle, that's our angle symbol. You literally just draw a little angle. I put an arc through it. You don't have to. WYZ. You don't have to go in that order. You could go the other way around and also say angle ZYW. Either way you want to do that is totally fine. Something that you might notice though is that point Y is always in the middle. See right here, Y is in the middle, Y is in the middle. That's because the vertex always has to be in the middle when you're naming it. That tells you exactly what order you're going to go in. Now, what if the angle doesn't look like this? What if we just have a single little standalone angle like that? I'd like you to draw that at the top. Well, sometimes you'll see a situation where maybe just the vertex is labeled. Let's say its vertex was A. You could then just call this angle A. Sometimes you also might see a number inside, maybe like a little 1. You could then also call this angle 1. So you could name it with 3 letters, or if only the vertex is labeled, you can name it with its vertex or a number on the inside. For this angle here, angle Y would not be an appropriate name for it because Y is the vertex of multiple angles. I wouldn't know if you were talking about this angle here or that angle there. So you just want to be careful with which name you decide depending on the picture. So now let's talk angle measure. And I'm just going to tell you, when I write things in this table, for some reason, sometimes things are shifting down. So hopefully it cooperates with me today. But angle measure, we're going to say angles are measured in degrees. So angles are measured in degrees, And keep in mind there are 360 degrees in one complete rotation around a circle. Now, the reason that's important is because angles technically do go around in a circle. We are going to deal with angles 180 degrees and less, but it's just something to keep in mind that that's where that comes from. So in this picture, none of our angles are labeled with measurements for us, so I'm just going to make one up. Let's say I told you angle ZYW was 120 degrees. It's just an approximation. Most of the time it'll be labeled. Then what you would do is you would say little m for measure, then put your angle symbol, and then ZYW equals 120. Having the little m there, that tells you it's like its numerical value, kind of like what we did with segments. So the measure of angle ZYW is 120 degrees. Acute angle, if that is if the measure of the angle is less than 90 degrees. Less than 90 degrees. Now, if you take a look at your picture here, again, we don't like to assume angle measurements, but I'm just going to go ahead and label this one in here for us. But if this angle is 120 degrees, then I'm going to go ahead and say that this angle next to it is 60 degrees. Well, that would be an acute angle because it's less than 90. It's going to be our example here is angle, or we'll say here the measure of angle XYZ is what we would call that one, is 60. And then a right angle, this picture does not have a right angle in it. A right angle is going to have a measure that is equal to 90 degrees. This one doesn't have it, but just so you know, if you do see a right angle, oftentimes it'll be labeled with that little right angle box, okay? So you'll either be told it's a right angle or you'll be given the box. We can't assume something's a right angle just because it kind of looks like one. An obtuse angle, that's if the measure of the angle is greater than 90 degrees. And we actually have one of those up here. Angle ZYW would be obtuse. So we'll put the measure of angle ZYW is 120. And then we have a straight angle. That's if the measure is equal so that is if the measure is, there we go, equal to 180. Yeah, see, this table is acting strangely. We can still read it though. Okay. It is equal to 180. And if you look up here, I didn't pick 60 and 120 just because 60 plus 120 is 180. And that's because this right here, WYX, is a straight angle. A straight angle is just going to look like a set of opposite rays. So we're going to say the measure of angle, and its name was XYW or WX, or I'm sorry, XYW or WYX. So XYW equals 180. And then interior and exterior, I just want you to realize interior means like between or on the inside. So if you take a look at our picture here, point T, we would say, is on the interior of angle ZYW. So interior is on the inside of an angle. So for example, point T in our diagram. And then exterior is simply on the outside of the angle. All right, let's take a look at some examples here. So it says refer to polygon A, B, C, D at the right. So that's this diagram here. This diagram is made up of a bunch of different angles. So right here, A, right, that's an angle. This little 1 here, that's representing an angle. So first it says name the vertex of angle 4. Angle 4 is right here. There's angle 4. So for your angles, look where the corners are, right? Where that corner is, where my two rays meet, that's where your vertex is going to be. And the letter we see there is a B. So our vertex is going to be point B. Name the sides of angle BDC. So let's identify that one. So that means we start at B, head towards D, that's our vertex, and then go back to C. So BDC is this angle here. So the sides of it are going to be the rays that come out of point D. So from D to B is part of our angle, and from D to C. So we would say ray DB and ray DC. Number 3, write another name for angle DBC. Well, let's look at where that is. D to B and then down to C. Well, when we name a vertex with letters, the vertex always has to be in the middle. But I could reverse my order here, and we could simply call it angle CBD. Or you could also, with this little 3 in the corner there, you could also name this angle 3. You could not call it angle B, because if you say angle B, I won't know if you're talking about this part or if you're talking about angle 3. So you got to be careful, because multiple angles start from point B. Write another name for angle A. So here's angle A. So this one, it's okay to just use the vertex because that's the only angle there. It's not being split up into multiple parts. There's no number there, so I can't use that strategy, but I could name it with 3 letters. Because if you look here, technically your angle would end up going all the way to D and to B. So I could call this right here, right? I could say angle BAD, or I could go the other way and say angle DAB. So why is angle D an inappropriate name for an angle in this picture? Well, if you take a look at where angle D is, it's in this corner here. So if you say angle D, I won't know if you're talking about angle ADC, or on the inside, maybe you're referring to angle 1, or possibly angle 2. In this situation, you have to be more descriptive because point D is the vertex of multiple angles. So that's what we're going to state here. D is the vertex of multiple angles. Okay. So that's why that would be inappropriate. And then last one on this page and this video, and then we'll move on. We're going to classify each angle as right, acute, obtuse, or straight. Now, I just want to tell you, this is really the only time that we ever classify an angle just by what it looks like. Typically, I have to give you angle measurements and stuff. Right now, we're just going to make an educated assumption based on the picture. And it got cut off for some reason. I'm not sure if it is on yours, but that should be a point M right there. So first one, angle MPR. So M to P up to R. If you take a look, that's going past 90 degrees, so that is going to be Then angle NPQ. So N to P to Q. And that's a very small angle. That's less than 90 degrees. So that's going to be acute. Then we have angle QPS. QPS. If you take a look in the corner right here, there's that little box. That's our right angle box. So we know for sure that this is going to be a right angle. Angle SPM. So S to P to M. Well, that's this bottom line here. Well, it's a bottom line, but isn't that also opposite rays, which then also is a straight angle. So when you have a nice straight line like that with those opposite rays, this is going to be a straight angle. So this, right down straight. And then last one, angle P. Well, that's point P. That's right here, but point P is the vertex of a bunch of different angles. So that's actually not an appropriate name for an angle at all. So we're going to write not an appropriate angle name. Okay. And then in the next video, we are going to move on to talking about congruent angles and angle bisectors.